Hi, I'm Mike,
I'm Don,
and this is the International Space Station.
Science Garage.
What do we got today? Balloons.
We have a balloon
Yep.
and a knit needle.
The balloon has got a pretty interesting tail on him.
It does.
But, okay, it's very colorful.
But what we have today is this say, which anybody can make if you want. It's called an electroscope.
You made this out of an ice cream thing. We got
Yeah.
Sicilian. Did you do this for me? Sicilian pistache, because I come from a Sicilian background.
No, actually I did it
gelato.
because it happens to be a perfect shaped jar to make an
Who
electroscope.
would have thought? It's kind of fattening, this stuff too.
Yeah,
What do you call it?
but it makes a great electroscope.
Okay.
There's two pieces of aluminum foil there.
Okay.
And they're hanging on this little wire, and you charge a balloon up with your hair.
Your head, all right.
Okay, and then you go like that, and see, look how.
Wow, so that stuff moved.
Yeah. Okay.
So it transferred the static electricity. That's amazing.
Yeah, and so the.
So yeah, go ahead.
So the charge repels each other. You have a like charge on each one of those leaves,
Right.
and so they push each other away. Now go ahead and touch the electrode.
Let's see what happens to the leaves.
Okay, so you remove the charge.
And it came into me.
It came into you.
I felt a
Okay.
little shock.
Now, so
I
I'm
didn't do anything.
charge this up again. See, look at that. And now here's a knitting needle. If I bring the knitting needle up, what does it do? Okay, nothing there. Let's rub it on the balloon, and now see what happens. Nothing again. It wasn't supposed to do that.
Why don't we try it again? Try it again.
Okay.
So what you're trying is you're hoping that it's an opposite charge. So it
Yeah,
won't attract.
yeah. But
Maybe it went in the other direction. Oh, look at that. Let's rig it. No, let's move it a little bit.
no,
Why did you have to put this in? If you just had this, if you just suspended this.
okay. Let's just.
The whole reason to have this in a jar is just so it's suspended, right?
Yeah, and that see,
Yes,
it's not messed up by other things. Like a small amount of breeze would mess these things
I
up.
see. So this is. How'd you figure this experiment out? Was this out
Oh,
of your
this
own
is
head?
any
Or did you learn
kid.
this-
No, any kid that's 8
Who's a
years
genius.
old. No,
Yeah,
any
no.
kid. I mean, this is a
Yeah.
classic thing that kids do for science projects, where you make an electroscope.
Okay.
And then you use it for investigating other forms, little static charge
You
things.
think I got any charge in my head? Can I try it on my head?
Sure, and maybe it's
let's
opposite
go.
charge.
Let's do this here. Trying to get a lot of charge.
Whoa!
at that.
Uh-huh.
That's pretty big.
And now let's see what happens. Wow. Okay. Now this electroscope has a gravitational component. You need gravity to kind of pull down on those leaves, so the charge force is now balanced against gravitational force. So electroscope like this would not work in a weightless environment
What
like
would
on
happen?
stage. Well, the leaves would just go. Whack.
Oh, they would. Okay, so
Yeah.
it would work. I mean,
But
you
they
would see-
just you wouldn't they
That
wouldn't
sounds
come
kinda
back
cool.
together. They wouldn't
What-
come back together again. So you wouldn't be able to tell the difference between when it was charged and when it wasn't
Oh,
charged.
because it was just floating. you're
Yeah,
saying.
because the
All right,
leaves
okay.
would just float. So
Yeah.
how could you make an electroscope that would work in a weightless environment? Could you make a simple thing? I mean, this is a Benjamin Franklin.
Impossible. No, it's not impossible. How can you do it?
I made one on Expedition 30.
Why am I not surprised to hear that?
And I wasn't able to make it until Joe Acaba came up.
Because you needed his head to make the electrical charge.
No.
Why?
He brought along a necklace, a silver necklace from either his sister or his mother or something like that. He had this silver necklace that he'd flown to station for them.
Very nice.
Yeah, really nice. A
Yeah.
fine silver little chain.
Yeah.
And so I took the chain, and I had
Did you
two.
give it back, Don?
Yeah, I only borrowed it for a day.
All right, okay.
So I had two strands of chain suspended between a plastic cylinder with a little wire like that, and the chain would just kind of just sit there and float. The two strands of chain,
Yeah.
and then when you take a balloon and you'd rub it on your head, and you would charge, the two pieces of chain would just pop out like that. And then when you took the charge away, then the pieces of chain would just kind of just float around again.
Wow. All right, so
We were able to take just the silver chain and make it into zero gravity equivalent of an electroscope.
I'm sorry, but what would the thing about the chain that allowed you to do that? It was because it was more material, or
Well, it was anchored on both ends,
Anchored, okay.
and it has very little friction in terms of holding its shape. If you took if you took tin foil like this and you anchored it on both ends, it would be too stiff, and the charges wouldn't bend it out.
I see. So you needed something that could take the charge, conduct
Take
the
the charge. It had to conduct a charge. You needed two elements so that they would both have the same charge and they'd repel each other.
Right.
But it had to have very little friction.
Right.
So, and here you have very little friction, but you're balancing charge force with gravitational force.
Mm-hmm.
You don't have the gravitational force, so the charge forces would try to push the links of the chain away, but they're bound on each end, and they just kind of bow out like that.
And if you just had a piece of wire,
Too stiff.
it was too stiff. If you had a piece of the tin foil,
Too stiff.
too stiff.
And if it was anchored on both ends, it would be too stiff. But if it was only anchored on one end, then it would just be flying around.
Yeah.
And you wouldn't be able to tell the difference between when it was charged and when it wasn't
Right.
charged.
So the chain
chain
was just right.
was just right.
It's like the Goldilocks thing. I think the point I'm trying to make, somehow, believe it or not, is that you have to find the right material. You have to find what's just right to show the phenomenon can still be at work, but you can't observe it without the right,
That's right.
combination of things.
And it took a while. I wanted to make an electroscope, and I tried it with aluminum foil 27 different ways, and I couldn't get it to work. And I tried it with a
so you were trying hard.
I
with
was
this.
trying, and I just couldn't get it
You
to
don't
work.
give up easy.